Hey everyone. So sorry I missed out on Halloween. It's busy doing Halloween-y things. It was more fun. I'm gonna put on some Lofi Girl music. Lofi Girl music. Cool. So we are gonna look at the Spark course grain scheduler today. And that's mostly, there's some stuff that I want to start tracking that the Spark course grain scheduler does not currently track. So let's go ahead and jump into that. Actually, let me close that tab. Let's grab Emacs, bring it over here. And, grab a terminal. Cool, bring it down here. Okay. Terminal mode. Okay, cool. So, yeah. First things first, let's figure out where we are, git branch. Okay. We're gonna update to the latest master. Fuck. Oh god, it hurts. I filed a JIRA for what it is that I want to do today, which is logging how long it takes for resources to get allocated. So we're gonna go ahead and we're gonna find that JIRA. Do that here. I'm happy that I'm starting to get single sign-on instead of like having the 12 different systems. Cool. So that's what we're going to do. Uh, 3666. Oh, hey, cool. We got 666. Log time. Waiting for cluster resources. Yeehaw. So CoarseGrainedSchedulerBackend. So the reason why we're going here is because this is actually, let's go ahead. Kubernetes. Ooh, okay. Kubernetes cluster scheduler backend. So the thing here is, right, like we see this extends the CoarseGrainedScheduler backend. I'm pretty sure the yarn cluster scheduler backend. We go take a look at this. It extends the yarn scheduler backend. Okay, yarn scheduler backend.scala, which extends the CoarseGrainedScheduler backend. What do I think about Beam? I mean, Beam is interesting. I would say Beam has definitely done a lot of overpromising and under-delivering when it comes to sort of its the cross-platform nature of Beam. But I think Beam has done a really good job of popularizing some streaming concepts, and I think if you're running on top of Google Dataflow, you know, it's a really powerful thing. I have some small bits of code in Beam, but really at the end of the day, you're asking someone who works on fundamentally competing systems what they think of their competitors. And so, like, I think Beam is pretty solid. I think Beam on Spark has a lot of room to grow from what I remember, and similarly Beam on Flink. So I think Beam's capabilities very much depend on which backend you want to use. Yeah, two-edged sword. That's reasonable. Okay, so what was my brain doing? I don't remember. Okay, cool, right. Cluster scheduler backend. Oh wait, no. coarse grain cluster scheduler backend. There we go. So let's take a look at some things that we might be able to fuck with. So that's removing executor, decommissioning executor. Okay. Interesting. Executor data map. 6. Okay. Request executors. Here we go. So when someone calls request executors, requesting additional executors from the cluster manager. So this goes ahead. Do request total executor. Okay. So, fuck. Request executors from the cluster manager by specifying the total number desired, including existing, pending, and running executors. The semantics here guarantee that we do not over-allocate executors for the Oh. Yeah. So this immediately just returns false, which is inconvenient because it means that I can't implement the tracking here, which is really what I want to do. I want to implement it in the CoarseGrained cluster scheduler backend. So if I have to implement it inside of Kubernetes cluster scheduler backend, so this immediately also says true. Yeah. So it's a non-blocking request, which that makes sense. I'm walking on a treadmill as I read through this code and try and figure out what I'm doing. Yeah. I don't get a lot of exercise as a software engineer, so I try and squeeze it in when I can. So pod allocator set total expected executors. Fuck, I was hoping that I could do it inside of the CoarseGrained cluster scheduler backend. But let's go take a look at do request total, at where this is called. So this is called inside of request executors. This just immediately says true. So, future successful true. So what do we do in the yarn cluster scheduler backend? Sorry, yarn scheduler backend. Do request. So this returns a future Boolean. Yarn scheduler endpoint ref pass Boolean pair requests. Yarn scheduler endpoint. Okay. Let's go ahead. Scheduler endpoint. Okay, yarn scheduler backend. Right. Receive. How do that? Okay. Okay, this happens inside of the application master. Makes sense. So this also immediately replies with true. That's so okay. We track pending. That's pending loss reason executor. Pending decommission. Num pending allocate. I mean, I work with Yarn and Kubernetes. I work with Dask and Ray a little bit too, but that's mostly for fun, honestly. It's kind of allocator. So, I mean, Scala's not the friendliest. programming language always, I would say. Hmm. Hmm. It looks like I maybe have to do this inside of allocators, and then I can't do it inside of the CoarseGrained Cluster Scheduler backend, which is reasonable. Just trying to think if there's another way that I can get around this. Yeah. Hmm. 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 Okay. Pod allocator. Okay, abstract pods allocator. I mean, this is fairly mutation heavy. A lot of the stuff inside of the inner workings of Spark is pretty gnarly. So okay, so we get that. So we've got resource profile to ID. Okay, resource profile. So, okay, requested total executors. Yes. So, okay. Okay. So, okay. So that's on task state. Task kill executors. Okay. So register executor. If executor data map, yeah, duplicate executor ID. If the executor is RPC, so okay. So add and go. Okay. Resource info. I mean, solidly sort of so, I would say. I mean, it's okay, right? Like, you can schedule JVM inside containers pretty easily. A lot of the annoying parts come down to sort of the networking abstractions and getting that stuff wired up correctly. Okay, so yeah, they are. They're painfully different. When users want to switch their code, um, there's a lot of knobs that they have to tune to get stuff to work, which isn't honestly it's not ideal, but it's okay. Okay, so this is where okay. Maybe I could maybe do it as a listener. Yeah. Yeah. Especially for Python. Okay. What I'm thinking of here is the listener bus gives us this executor ID and data. So okay, we've got a few things that we could do. I could add a listener, but let's go take a look at CoarseGrained Scheduler Backend. I don't think we currently post. We don't post any listener bus message. Yeah. Okay. Here's my plan. I'm just going to sketch it out in comments really quickly. Sketch. Async update. Waiting times. So, okay, we've got two options here, right? We could update request times. Sketch async. Okay. So here we go. We've got this registration TS, which is pretty close to what I want. Figure out when we asked for this executor. We did. Let's type option long so then what we would do is okay, so okay, cool. Num existing plus num additional. executors. Wait, why is it only in the default profile? What? What the fuck? So I'm requesting total execs per resource profile. I want to see requested total executors per resource profile. Yeah. Okay, yeah, that's because this is just doing the default resource profile. Here we go. Oh, what? Okay. Resource profile ID to num execs. Okay, well, a few things that we're going to do. Really, oh, this is num additional. Okay. So what we would do here. Oh, is Emacs. I'm just more comfortable with this, strangely enough. Requested total executors per requested executor This does have to go inside of synchronized. I don't like this, but I think that's true. Resource profile to num execs. So who calls request total executors? Request total executors. That's a final override def, but that means it is public. Okay, let's take a look at it. Okay, that's the target. Wait, resource profile ID to num execs. Oh, that's just resource profile to num execs. Fine. Then what we do here, requested total execs per profile dot clear. Like this is legit, but it's also kind of inconvenient. Because it means that we don't really know what the previous time, like the previous number of requested executors are. So we don't know the number of additional executors being requested. So that's not a party. Cool. Thank you. I hope you get some rest. Have fun in Oslo. So now, okay. So I think, thank you. So look, this is legit, right? Because we want to clear it, because we really don't care about the, sorry, I stepped funny. I get distracted sometimes. Then, yeah. Okay, so the problem is we don't care about this except for the purposes of tracking. So, sleep well, ones or zeros. I don't want to get rid of the clear, because like the benefit of doing this clear is like, yeah, we're guaranteed to like do not bad things here. Oh, hey, Professor Timbit. How are you doing? Yeah, you have a little body. That's a good little body. But, like, it's easier without resource profiles, because, like, the amount of, the amount of work that we have to do is not unreasonable. So one option here would be val delta. Requested totals. Then what we would do is delta execs. Hey, little bud, what are you going after? Are you going after my Cat 5 cables? Just because they're called cat cables? Okay. Could take this, yeah. Delta execs. Then we will go for each. What's up, bud? Sorry. Is everything okay, little bud? Oh, your ball fell. Oh, poor little bud. Okay. There we go. Okay. Then we grab delta execs, and we do some stuff with it. Oh yeah, that already assumes that they're allocated. Okay. So we don't have to worry about that case. So then delta execs, we want to update the time that we're asking them for. Although really, I actually don't care about our... Oh, except that is stored by resource profile to num executors. Okay. So then delta is greater than 0. Okay, let's go to request total. Just executors. Do request total. Okay. Do request total. Okay, yeah. Okay, yeah. Here, so we would add the delta. Add the number of additional executors plus our current time. executive profile. Otherwise, delta is less than 0. We would probably want to take an element off the back. Like the other thing is, I'm beginning to wonder if I'm doing this in the wrong place. Let's go look at the executor pods allocator. Okay, executor ID counter. Okay, so that's not. Yeah, okay, so like we could do this. Newly created executor. Oh yay! I'm so glad, Sam. RSMDG. That's awesome. So what I'm debating about is essentially where are the right places to put this code, right? Do I want to put it in the executor pods allocator? Part of my stateful set pods allocator. Like, like this one has no idea how many things are actually pending, right? Like that's the deal. So I think this is the only place that I can. I think this is the most reasonable place to put it for now. Yeah. Okay. So okay. Okay. Adding the execs. we are now class executors. Let's profile. So the trivial way that I could do this is I could just put like X instances of that like thing in it, and then we can go forward, but I don't, it seems wasteful from memory. And potentially very wasteful, because like we could be asking for like 10,000 executors, and I don't. Okay. Times 0 if times 0, 1 is greater than C. Else times equals times dot rest. Okay. B minus equals times I1. Okay. I mean, this is some really not very pretty code, unfortunately. But also ones or zeros, you should get some rest. It's important. Honestly, like when I don't get sleep, I get really sad. And you know, I hope you get some rest. But okay, sorry, brain. Not to overstep. But okay. So here we go. I'm gonna write down what I am intending to do. Okay. Okay. Consume minus delta elements from our array. Elements. We're adding delta execs rather than store delta copy. Just say this code is not pretty, and I don't like it. I think I can do better. But at the very least, let's get something working first, and then we can try and make it prettier later. Um, 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 hmm. I feel like this is going to slow stuff down because this is doing a lot that I don't. So my default when I'm working in the CoarseGrainedScheduler backend is to try and kick stuff off into a separate thread, but that's not going to work. But I mean, I guess this isn't doing too much. I think this is, yeah, okay. This is doing more than I want, but probably not too much. Okay. So, okay, cool. So then, over here, oh, fuck. This introduces some contention here. Not great. Not great. This, if I block on delta XX and then this thing needs to block on delta XX, then while an executor is registering, cannot, or is this already synchronized? I think implicitly this is synchronized. Yeah, because the executor data map, I think it's synchronized. It's okay, okay, we'll get back to this. No, it's not. This is the part where it's synchronized. Well, what could we do? So, I think maybe the most reasonable thing to do, now that I'm going through this, is we could add a new listener bus message. Because I don't want to introduce more blocking things inside of this. That's just not a party. So we're going to get rid of delta. Probably end up recreating my logic somewhere else, but for now it's gone. What we'll do instead listenerbots.post. So this is, we're dealing with the base layer in Spark, and that's the common layer that Spark has for both Yarn and Kubernetes and Mesos. Not a stupid question. Not a stupid question. And so there's sort of some common elements, and so that's why it's going to look a lot like the Yarn stuff, because and what I'm trying to do right now is I'm trying to come up with a way where I can solve this problem such that I can track this information for both Yarn and Kubernetes. Spark listener executor request updates, and then we'll do this outside of the synchronized. So and I'll actually just dump this in here. And over inside of total. This is going to be okay, this is a special case. Dude. Instead of going directly to do request total executors, what I'm going to do, oh wait, no, because that's going to be a synchronized entry into a synchronized. No, if I already hold the lock, and then I enter there, resource profile ID. Okay. Yes, you should definitely get some sleep. Being awake for 3 days is not healthy. It's very, very bad. In fact, yes. Okay, I'm going to take a bio break myself. I will, or okay, open. Oh, thanks 100. That's sweet. Okay. Question myself. We delegate. Yeah, it'll be recorded. It'll be recorded. Question to myself. Yeah, okay. To do. Well then. We got to do it here, unfortunately. Parts. To do Holden post listener buzz message. Okay. Ciao. Okay, yeah, and I'm gonna actually really take a bathroom break for real this time, and I will be back. Okay. And we are back, or we will be back in a second. I will find the button to press. Button. Hey, Professor Timbit. Okay. So, I think, yeah, that's what we're gonna do. And actually, yeah. You know what? This way I can put my listener bus message outside. Requests. The synchronized block. And then, yeah. Okay. Do is we set this. Oh. Executors equals request map rp v rp.id. Does that seem... Sure. And then... Cool. Now the listener bus is a little lossy, and so, you know, it's going to be fuzzy, and it's going to sometimes get things a little off. But I think that's okay because it lets us sort of offload this stuff out of the hot path really easily. Does that seem reasonable? Because the alternative, right? Another very good alternative would be yeah, okay, so another legit alternative could be to store the old version right before this, get the new version, and then compute it asynchronously. I like using the listener bus. I like using the listener bus to or I could just go ahead and post deltas. Okay, I'm going back and forth on what I want to do here, which is not. You know what? Yeah. Okay. Here's what we're gonna do. Okay. Oh yeah. I'll rec ts. Okay. Maybe we can push this to the listener bus. And I think what I want to do is we're going to revert that. And then what we're going to do here instead and then compute deltas, or so total executors per. Or I could, oh no, because everyone overrides do. Um, hmm. 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 So I could make. I don't know how I want to handle this. Definitely want to kick it off into another thread. Um, hmm. Do I want to kick it off into another thread? Let's total executors. Plus total. Okay. Okay. Total. Profile. Yeah. Okay, so we'll go through that for now. Oh no. Hmm. Okay. Override def. Request total. Okay. Private def. Compute deltas. Profile. Is type. Really, I only care about the IDs. Hold. Mm. Okay. Compile. It's gonna fail, but um, we'll give us something to start with. Oop, oh, 3 kilometers. Oh. Hmm? Oh, Phoenix is here?
Yeah.
Oh, cool. There's the lights. Yeah, cool. I'll be back. See you all soon. Do. Lights. Camera. Moderate action. Go, Professor Tippett. Come on. Let's go find the lights. Let's go find the lights. Yay! There's the installing machine. Oh, yeah. Sure. Installing machine.
Installing machine.
Okay. I find list.
There are fewer animals on the floor in here.
Oh yeah. Okay, yeah. Oh yeah. Trying to fix the phone wiring.
Oh, right.
And installing the window AC units.
And the window AC units are going where?
Oh, one of them goes here.
Okay.
The other one goes in Carolyn's room.
In the window close to the same wall?
Yeah, yeah.
Yeah.
But like, if it doesn't make sense, maybe whatever. Which, like, if there's a different window would fit in better, like that's okay, right? Like I don't have like super strong field dots.
Sure.
And then we did the measuring the wood. Yeah. Oh, and the hanging of the paintings and stuff.
Yes.
Hanging
A
more
whole bunch of
paintings.
things to hang in the
Yes.
TV room.
And install pooping. Okay, and then then there's the future projects.
So there's pooping?
Oh, there's the pooping project for later.
Do I want to know?
No, it's the November 5th delivery from Toto. Yes.
Remember the 5th of November? Gunpowder,
Reason and
plot.
plot.
Remember the poop of November?
Okay, yeah.
Gun pooper and poop?
Yeah. So I think the LFX lights and the other lights and then paintings.
Okay.
And then I think the plate stuff. Yeah. And the grab bars.
And the grandmas.
And I think that's probably a lot. But if those things finish, we have more things.
There's always more things.
Always more things. Oh, and we have questionable cheesy bread that we baked yesterday
That's
in the
what
bread
Carolyn
machine.
was saying. She said you have a new bread machine and you've got 1.5 breads.
Yeah. That's optimistic. But you're welcome to try.
0.75 bread?
Yeah, you're welcome to try our interpretation of bread.
Okay.
It's on the cutting board.
Okay.
It's a very unique interpretation of bread, I would say. But it does have some nice garlic flavor. Yes.
Alright, and then I go down to the bonus room and it's MR16. Their whole...
But okay, I'm back, and now we will press buttons. Okay, so we can see here it made sad. Oh, it found mutable hash map required map. Oh. Wait, what? Wait, how? Why is this giving me back a mutable hash map? Wait, what? Darnation. Okay, line 782. Yeah, okay. Old resource profile to numexecs. And resource profile, Okay. There we go. There we go. Okay. Oh, fuck, I didn't need clean. Oh, well, whatever. It's fine. I guess I'll rename this to update exec request times. Okay, cool. TBD make async. I don't know if I want to make this asynchronous or not. But that's okay. So whatever. For now, so executor data map. Okay. So I could use this guarded by annotation here. I don't. Executors pending decommission. So why are we not? Okay, executors pending decommission. Decommission. Like. I don't know. Okay. Well, I just don't. Man. Okay. Well, let's write a non-async version first, and then we can think about whether or not it needs to be asynchronous. New profile. Is v minus old profile dot get or else update exec request time profile ID if delta not zero. Cool. Private def update exec request. Profile ID. Delta is greater than 0. Else is less than 0. So then private val exec what's times hash map int int array of profile IDs to the times that executors were requested for. Okay. Exec. Okay. T times is equal to exec request times dot get or else update profile ID. Okay, hash map, hash map, get or else update. Okay, with Scala hash map with default value. Okay. Now I want the mutable. 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 Hash map. Okay, is there a okay. Oh, yeah, I lost track of the fact that I was not walking. Yeah. Hello, Professor Timbit. How's my little buddy doing? Hey, bud. We've had this conversation before. Okay. Okay. Wait. Profile. D? Wait, what? Oh, okay. So this is. Okay. New profile ID. So if the delta is greater than 0, times dot append delta. This. Scala array. List. Hmm. 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 Doot. The performance. Don't. Oh, yeah. What? Why won't? I don't. Yeah, I don't want to make a copy. Let's take a look at Scala's collection API. Don't quite. Don't really want a wrapped array either. Kind of want to. Scala FIFO Q, where I can mutate the head object. Can I mutate the head object in a Scala FIFO Q? Can I peek at the head of? Yeah. Okay. Yeah, Scala collection mutable queue. Really, I guess that's what I want. Exec. Yes. Oh, Scala collection but mutable. Okay, it's not depend, it is like append is. Why is that not? Wait, you were saying that append, but at the same time, this is saying Scala collection mutable Q, Scala collection mutable Q. Okay, 2.11. Okay. Okay, I guess code was felt to be too readable, so let's do this. Okay. So we call append. Was Professor Timbit helping? Oh, Professor Timbit, I'm suspicious. Oh, it depends if it's an approved stuffy or not.
Approved stuff.
Professor, you know better. Why you gotta narc on me, yo? I mean, yeah. Okay. Okay, cool. Oh, yes. I mean, he's much like his mom in that, yeah. Well, no, but also, like, his moms maybe don't do so great when people don't pay attention to them either, and may or may not act out. Okay. Consume, from the head. Well, C is greater than 0. Yeah, okay, yeah, we're ending up just rewriting this logic, but that's okay. If okay, yeah. Times dot, can I peek at the top element? That's what we want to do. If h0 is greater than C, then we're going to mutate H. Can I mutate H? Fudgesicles. Are Scala tuples mutable? Ah, shit. Okay. Not actually mutable. So instead, we'll make a very basic case class called Case class back info. I am count time is type. Okay. If h dot count h dot counts else c c minus equals minus h dot count. Oh, yeah, okay. Cool. Okay. Line 808. Wait. Scala, case class, modify, change a field. Don't want to do copy. Unless I can swap. Yeah. Like, okay. Well, yeah, fine, whatever. Let's go ahead and switch this back to a tuple because I'm lazy. So I guess times dot updated first rec h0 minus c h1. Okay, so for real this time, yeah. Else c equals minus Wait. Yeah. Yeah. Okay, so instead of our info, it's info. Okay. Wait. What? Oh. Tuples. Dot underscore one. I still am. Wait. What? That's. What? Okay. Um. Uh, uh, Wait. This is saying that this takes constant time. And that's a. Oh. Yeah. Okay. There we go. Is. Why is this not doing what I thought it would do? Like, plus equal, that's, times is of type q int long, and this is saying that, int. This is not making sense to me. Like, this should give me ease through. So you would think. It swaps the. The downside of being. Oh, row machines are fun. Row machines are fun. Okay. These should work. Okay. Yes. Okay. Yeah, okay. assume as if dude dollars and allocated. Yes. That's not good. Try not to die. Okay. Then we do. So yeah, okay. We'll do these for now. Okay. Do request total. Total. Do request total. Yeah, okay. So then instead, this one, just go ahead and update exec request time. Profile ID is going to be default prof. And this is going to be num additional executor. Okay. So, yeah, I mean, those are constant. Okay, I think that's fine. I think this is fine. Dude, constant time walk. This doesn't change the big O. It is going to change the constant, but instead of default prof, you should release leave ones or zeros. It compiles. It's probably not functional. The next thing that we need to do. Okay, so try using a queue. track of exec request times. So then what we'll do here is inside the registered executor. This is going to go ahead. Resource profile from ID. Okay, yeah. Val rec time. Exec request time. Dot get. Resource profile ID. Head option dot map exec oh yeah, okay, t dot underscore 2 okay. Underscore 2 okay, and then what we'll do here is dot map okay. Times so if times is defined, if times has a head, it's going to be h underscore 2. Yeah. And then if h 1 is greater than 1, oh yeah, regardless times.dequeue, and then yeah, if we need to put it back, then we do this. So C, it's 1. Okay. That's kind of gnarly. Let's see if it still compiles. Not loving this code, but it's okay. Oh yeah. Improve flat map. Oh wait. Wait, what? Okay. So this is kind of rough. Kind of very rough. But okay. We've requested this. Grab it. Hi. Ignore. If we've requested executor figure out. Okay. I think I need it guarded by or oh no, I have it there already. Okay. So try and get the time from the queue if it's defined. When that executor was requested. Cool. So that's good. Values of good, which are flexible. Okay. So then this makes okay. Execute our data. Execute at param ts the option. Okay, the request what time this executor is most likely at. It's a bit of a stretch, right? But like, yeah, I think that's probably. I'm gonna expect this to fail now, but it might only fail in test compile. Okay, no, it does fail. Okay, line 281. Wait, what? Oh, here. Okay, that's fine. New line. Solid maybe. Solid maybe. What do we think? Okay. This is almost certainly going to fail when we do test compile, but that's okay. Okay. It's still progress. Right, okay. To the executor data. Okay. That's solid. Yeah. Oh shit, I forgot to resume. Oh well, whatever. Hmm. Honestly, I'm kind of surprised. I guess this shows you how little test coverage there is here, which is actually kind of terrifying, but that's another matter. Um, do huh. Okay, there's no test coverage for this? This is not good. Definitely not good. Like you would want some test coverage? But okay. Yeah, it's really weird. CoarseGrained Scheduler Backend Suite.Scala Executor data. No instances of that. Okay. Um, that's a thing. Okay. Hmm. So this sends a message, which is Spark Listener Executor added. And that okay, Executor Allocation Manager Suite. Okay. Spark Listener with Cluster Suite. Okay, let's go take a look at Spark Listener with Cluster Suite. Okay. Um. Okay. Yeah. Hmm. Okay. I was really hoping that a test would fail. It looks like we just don't test this shit at all. So that's right. Hmm. That's okay. Added executor info. Okay. What? Wait, what? 610's executor info. I guess technically speaking. So, okay, I'm expecting this to fail, but Apache.spark.scheduler. Spark listener with cluster suite. Okay. Yeah. Yeehaw. Okay, that's why. Okay, okay. Okay. Oh. Override. Override. Hmm. Okay. Hmm. Executor host, total cores, log URL, attribute. So that goes to that, that goes to that, that goes to that, that goes to attributes, and then default resource profile ID. Okay, yeah. And then this is 0. Whatever, it's not 0. Oh, executor data line. Oh, there we go. Registration TS. TS. Okay. Okay, now let's go find JSON protocol. Or is it? Okay, yeah, okay. JSON protocol Scala. Although, actually, wait. Option. JSON protocol.scala inside of util online 1223. Oh, okay, yeah. Registration TS. JSON option. Registration TS. Match. Case. TS dot extract. STS. Registration TS. STS. Oh yeah, okay. Let's go over to executor info. It's none, none. Make these distinct from the executor data ones. Executor info. Line 39. Okay. Executor Allocation Manager Suite. Yeehaw. Executor Allocation Manager Suite.scala. So 47. Listener with cluster suite. That's registration time. Okay, Executor Monitor Suite. Executor Monitor. Hey, Professor Saurus. How's it going? Are you having a good one, my little professor? Are you having a good one, my little professor? Executor Monitor Suite, line 269. Okay. JSON Protocol Suite, okay. JSON Protocol Suite. Inside of util, okay. Line 95. Okay. Oof. My feet are starting to get tired, so that's probably a good sign. Oh yeah, we've been doing this for about 2 hours. Okay, wait, what? Oh, okay, yeah. No, let's do core test. This is going to take a while, but I think this is a good place for us to stop. Core tests compile. Not really tested yet, though. Okay, and now we'll push this upstream just to a branch on my personal GitHub. But yeah, cool. And so it'll take a long time to run these tests, but probably whenever I get some more free time, which won't be for a while because I go on call at 9 o'clock tomorrow morning, we'll come back to this. Probably, honestly, next week, we'll take a second look at this. Bye, y'all.